everyone here on the webinar from Manila, Philippines, and welcome to the 34th session of the Circular Economy webinar series. I am Erin Sinogba. I am the Project and Knowledge Management Lead of ADB's Regional Technical Assistance Project on promoting action on plastic pollution from source to sea in Asia and the Pacific. And today I am the session moderator. So to just give a bit of a background on the Circular Economy webinar series, this is a regular ongoing webinar series where we feature a range of different technology solutions, new business approaches and business models, emerging issues, and case studies that showcase the possibilities of the circular economy in Asia and the Pacific. And today, it's very exciting because we are going to virtually take a trip to Latin America and listen to a story about how a community project led to the development of an innovative technology that transforms low-value plastic waste into sustainable building materials. So why does this matter to Asia and the Pacific? Well, as our region continues to experience growth, we are seeing rising infrastructure development and construction output across multiple sectors. However, this comes at a cost as the building and construction sector leaves a massive environmental impact. According to a 2023 report from the UN Environment Program, 37% of global energy-related carbon emissions come from the built environment sector. And along with this, there are multiple impacts on air quality, on water consumption, waste generation, dust, among other impacts on the environment. And this is the result of the production and use of key construction materials such as cement, steel, and aluminum. And so among these, cement is the most widely used construction material, and Asia accounted for 80% of all cement production. The amount of cement is embedded in the region's existing infrastructure, and it has been growing in the last 30 years with all of the rapid development happening in our region, and will continue to grow in the future. And then in parallel, we have another pollution crisis. Asia and the Pacific is at the center of the plastic pollution crisis globally, with up to 12 million tons of plastic waste entering our oceans every year. And leading to damage in our ecosystems and entering our food systems and now our bodies. And just like our building materials, the production of plastics is also responsible for significant greenhouse gas emissions and other environmental impacts. Without action, we will continue to experience negative impacts to our environment. And for this issue of construction, as well as the plastic pollution crisis, circular solutions and business models will be key to curbing plastic pollution and reducing the environmental footprint of the construction sector. And so with that, I'd like to now introduce today's speakers, and we're very lucky to be joined today by two experts, one based in Singapore and one in Costa Rica. So we have a very global panel for us today. First, we have Donald Thomson, who is the founder and CEO of Center for Regenerative Design and Collaboration, or CRDC, which is a zero-waste incubator in Costa Rica that harnesses the commercial potential of regenerative design, and CRDC Global, a world leader in circular economy solutions for the construction industry. A lifelong builder, developer, and industrial innovator, Donald holds 6 international patents in building product design and is widely recognized as a disruptor in the field of low-carbon concrete. And then second, we have Nicholas Kolesch, founder and director of NK Circular Economy Consulting. Nick brings experience from over 25 years, spanning Europe and Asia in commercial leadership roles in the petrochemical sector with Ciba Specialty Chemicals and the Borealis Group. Most recently, Nick was vice president of projects at the Alliance to End Plastic Waste, a nonprofit organization established by leading companies in the plastics value chain. So welcome to our webinar series. Don and Nick, over to you.
Hi. Well, good morning, everyone, and thank you so much for this opportunity. It's really incredible to be able to communicate around the world as we can nowadays. So it's thrilling to be with you. CRDC actually has a bit of an interesting background. As Aaron had mentioned, I'm a builder developer. I moved from Canada to Central America 35 years ago. So I've been in the region a long time. I made a career out of development and specifically social housing was in combination of social housing and high-end resort development, looking for that symbiotic and financial tie between what we could do with foreign investment and how could we house people. And in that process, we learned that probably one of the most valuable things that you can do for a family. If you want to take a family out of poverty, you should build them a quality house, a house that's got appreciating value. So we all know that there's a big problem. Um, Again, I've been in Central America for 35 years. When I came to this region, the rivers were pristine. There was no plastic on the beach. It's saddening. It saddens me deeply to see this quantity of plastic. This picture taken from the Rio Las Vacas in Guatemala. This quantity of plastic moves now. Thank God for the ocean cleanup and this barrier that put. But previously, this plastic moved a couple hundred miles down this river off to the Caribbean coast and into the Honduran reef. Tens of thousands of tons of plastic in one of the most pristine, beautiful areas of the world. We all know the problem. We all need, we know we need to do something about that. The solution is really we believe the solution is in creating these assets in a giant industry. The construction industry is huge. In fact, it's so big that if we only replace 1% of all of the plastic that we utilize in the world right now, or we manufacture in the world right now, 1% would be equal to the amount of aggregate and concrete that we produce every year. So it became clear to us as builders that one of the viable spots, one of the places that we could create economic benefit with this waste material was creating a lightweight synthetic aggregate. So we've taken an approach, a triple bottom line approach, a sustainability pillar approach of economy, society, and environment. So it's our goal to affect all of those things, to do it in a profitable way, and to help as we go. This particular project right here, which we call 100,000 pisos or 100,000 floors, from an impact perspective, it's one of our favorite. We work closely with Habitat for Humanity. We have for many, many years. But this particular project is Habitat for Humanity recognized that there is hundreds of thousands of people still in Latin America that live with dirt floors. Those dirt floors have been proven to create all kinds of health issues with the children, learning issues, just a whole set of problems. And so a number of large cement industries, ourselves and Habitat for Humanity are now working at embedding this plastic particle that we make that we call resin 8 into the floors and of the project. So this is societal. We can affect and we can help with the societal aspects of this triple bottom line approach. Obviously, we know the problems, right? Tourism, the environment, the economics behind this just don't work, obviously. So we've named this kind of plastic tragic plastic. Plastic that's made its way into the environment, plastic that is really the epitome of the problem. And what we did with that was we decided within our industry what was the bulkiest material that we could replace and actually improve the qualities of our concrete products and our asphalt products. So we went about synthesizing a sand, a lightweight aggregate that has exactly the same qualities and gradation that you would find in your normal block sand, but at 1/4 the weight, which brought certain qualities in when added into the correct amounts and very low amounts of 10% or less. It brings in stronger impact strength, at times better compression strength, better insulation value, whole series of improvements to standard concrete. We started this process in about 2018. We started in Costa Rica. We joint ventured with the largest concrete products company in the region. And we pretty much got it right off the start. We were able to make this synthetic aggregate, which is visually benign, environmentally benign, and could improve our products. After we realized that the standard construction industry would be willing to purchase this and be willing to get involved, we started to reach out across the world. And now we have facilities in 4 countries, 5 countries, and we make this product. This product's called Resin 8. In the plastic world, we have 7 kinds of resin. The problem is typically you have to segregate those resins in a way so that you can get pure stream recycling. What we did was we said, well, a lot of this plastic can't be recycled. If we could commingle everything, we said resin is resin is resin. If we could commingle these 7 kinds of resin, we could create an 8th resin, which we call Resin 8. The resin that we don't look for any particular plastic type, but we look to mix it at a bulk density for our aggregate. So the bulk density we get is about 1/4 of the weight of sand, but we're able to make this product so that it adhered extremely well. So the Resin 8 that you see on the left-hand side of your screen is 80% commingled waste plastic taken directly from rivers or beaches, from hospitals, from schools, from municipalities, from post-industrial sources. Any source of plastic, we can accept that. We granulate it, we extrude it, with minerals, calcium hydroxide and pozzolans, 20% minerals, 80% plastic. We inject water vapor in during the extrusion process. It creates an open cell structure. So it's a little piece of lava rock that we then break down, and we turn it into the exact size and gradation that we'd be looking for in our product. A couple of years ago, we recognized that product was unique in its ability to absorb. And we felt that we could actually absorb CO2 with the product by coating it with calcium hydroxide and exposing it to flue gas. For the last 2 years, we've been working with PA Consulting in Cambridge, England, to develop what's really the first carbon capture and utilization aggregate, synthetic aggregate. So at the core of the product that you see on the right-hand side of your screen is the exact Resin 8. On the outside, it's completely covered with the perfect facial structure for concrete, calcium carbonate or limestone. And it weighs about 1/3 of the weight. We follow the circular economy very closely. In fact, in 2016, our REAP model, for us, REAP is circularity. Our REAP model was awarded the People's Choice Award in Davos for circularity. And since then, we've stayed extremely true to it. So what it really stands for, the value proposition is recover, enrich. Recover and enrichment are the input side of a regenerative cycle. And on the outside, appreciation and prosper. So we take that waste plastic, we recover it from numerous sources. We then take and put it into our factories. We enrich that into the very useful construction aggregate that we have. We then can turn that into a whole variety of important standard concrete products that we always aim to increase their value. And then we appreciate those products by putting them into infrastructure and or housing and construction. Construction remains today to be one of the areas that we can see appreciating value over time. So effectively, we've sequestered the carbon in the plastic, but we've also put it in a position where it's going to raise in value for at the same speed that you'd see any real estate asset appreciate. So from a financial perspective, it makes sense. And from an environmental perspective, it makes sense. And obviously from a climate perspective, it makes sense. So this is our format. That's our REAP program. We have a great example of that value proposition at work in Guatemala right now. We're working with the ocean cleanup to take the plastic out of the river, divert it from incineration. We teach the children in the schools regenerative design. We work with the United Nations Development Program in South Africa and Samoa and in Costa Rica and the United States, teaching now tens of thousands of children about regenerative design, this REAP program. What we provide the kids in this process is simply a bag that 2 bags a month. They take that bag home. They tell their parents, put all of the plastic in the household in this bag, and then there's a promise from our company to the schools and the children that every bit, 100% of that plastic you bring will build your community. So we call it the bag that builds. It's been a highly successful program. We then gather that plastic, and then on the output side, we start to develop housing, and we start to develop infrastructure. And then the community benefits from the educational side and the plastic recovery side. So we make a massive and pretty profound difference into the societies that we put our plants into. We have these 4 plants around the world. We started in Costa Rica. We, even despite COVID, we were able to open pilot plants. We have very good construction connections across the globe. And so even despite COVID, we decided that it was a good idea to try to see what the construction sector would think about this product. And so we opened facilities in these various locations, like Costa Rica, the United States, and York, the United States, South Africa, and Australia. And now we're in a position where we're expanding. We have pretty aggressive expansion plans. We call it the 2020 vision. It requires quite a bit of vision to tackle this program this project on a global scale. So our goal are to build 20 plants around the world that are capable of doing 20,000 tons each. That makes us a pretty major plastic transformer on a global level. We feel that we'll be able to accomplish that now within 4 to 5 years, and then after that we expect a pretty exponential growth. We feel that wherever you have plastic and you have a concrete facility, you can have a resin 8 facility. And it's these localized facilities in various geographic regions that it's probably going to be a project that moves the needle on this tragic plastic problem that we're all facing today. We work with some very large companies. We were there. I think we were the first company that the Alliance to End Plastic Waste funded. We work closely with the United Nations. We work closely with Habitat for Humanity and some very large cement companies. So I'm going to hand it off to Nick now to be able to go into more detail and specifically about Asia. But thank you very much.
Great. Thanks so much, Don. Again, it's an inspiring story that we've seen, and I've had the privilege of kind of being part of it since 2020 when I first came across the technology during my time with the Alliance. And indeed, it's a great solution to address the plastic waste challenge. And of course, working in this region and around the world, we know that that's a big issue that we're all looking to address. Again, everyone on this line knows very much about our plastic waste management crisis in the region. We have a huge amount of plastic waste that is not well managed today. We know effectively that we need to improve source segregation. We need collection and processing infrastructure that's lacking in the region. We know that the informal sector is playing a critical role, but they tend to focus on the higher value plastics that they get paid for. And we know that we're a growing region, right, with a lot of income increasing. The consuming class is going to double to 163 million households by 2030. And we need to build out recycling solutions and solutions that are going to drive that circular economy forward. And that's where I think this building and construction market is really a great opportunity to leverage what we call an industrial symbiosis between the waste of one industry becoming the raw material of another. And as Erin said at the outset, right, the building and construction market, the concrete market is massive, and it's huge in Asia. There is a tremendous amount of infrastructure that's being built, whether it's buildings or roads. Growing middle class, we want improved housing around the cities of Asia. And certainly there's a growing demand for green building products and sustainable construction. We know that there's also a crisis of sand mining or aggregate mining from natural resources in the region. So if we can replace that with a synthetic aggregate, again, that's another benefit. So we're really looking at industrial symbiosis to drive that opportunity for circularity in the region. And again, as Don indicated, there's a lot of opportunity for growth, and we want to see this region as part of that 2020 vision. So ensuring that we are building out plants and the ecosystem of CRDC and the REAP methodology in places like Indonesia, the Philippines, Vietnam, Thailand, and Sri Lanka. We have actually projects underway at the moment being developed in Indonesia, India, and Saudi Arabia, and also looking to partner to see where we can grow more in the region. And again, what's really important is that we're not just talking about a product here, we're talking about creating that circular ecosystem. And what we really need to see is that plastic waste being collected in a way that enables it to be utilized by a CRDC plant, for instance, to turn it into Resonate, getting that material into construction aggregate, getting it into building and construction products, and getting it into housing. And again, this REAP ecosystem is what we're looking to build to drive forward regenerative solutions in the Asia-Pacific region. And the benefit that we see in Resonate and the work of CRDC, I think, is twofold from an economic point of view. Obviously, there's a revenue side related to the management of plastic waste. Again, in our region, there is some challenge in getting the revenue in for basic collection. But on the other side, we are seeing plastic credits becoming a more prominent mechanism to cover that cost. But ultimately, we want to ensure that the plastic waste is not ending up in one of those typical outcomes that we see in the region and around the world. And at the same time, as Don indicated, we have a great opportunity to drive revenue generation through the sale of Resonate. It is actually a small component of an overall building and construction project, and it doesn't take up much of the actual concrete formulation. Normally, the product is used between 5 and 10%, which, again, from a cost point of view, makes it very economic, especially when considering the benefits of carbon sequestration and all of the benefits of lightweighting and performance improvement in concrete. So opportunities for revenue generation through implementing the project. And at the same time, the Bag That Builds program is a great way to engage communities, engage societies in that collection of plastic waste. And again, as Don indicated, we can take all plastic waste. It's been a challenge to say, well, we only want this or that part of the plastic waste stream. We can take everything into the Bag That Builds and get it into a Resonate plant. At the same time, we don't necessarily want to recycle material in Resonate that could be mechanically recycled. So again, if there's an opportunity to pull out PET bottles, to pull out HDPE rigid fractions that can be sold, then by all means, that's what we're aiming for. We're really looking for the residual plastic waste that doesn't have a home today, and looking to implement the Bag That Builds as a mechanism to get that material collected. And once it's collected, there's a very refined plant design that exists in these locations that Don indicated. We want to get that material into the plant. It's shredded, it's commingled with mineral additives, 80% plastic, 20% mineral additives. It's put into an extrusion process. It's coming out, it's cooled and then granulated to meet the requirements of the customer in terms of the size and nature of the particles going into the concrete formulation. And again, with Resonate Core, a post-production step can increase the carbon sequestration potential. So effectively calcium carbonate encapsulating those particles of Resonate. And when we talk about the actual plants themselves, each plant can take approximately 21,000 tons of plastic waste. Typically, the plant's running 3 lines, about 3.6 tons per hour. That's generating around 26,000 tons per year of Resonate, which can also then result in about 12,000 tons of Resonate Core. And that product effectively can go into many, many applications. We've seen it being used in the US in ready-mix products with a company called Beltertech. We've put it into blocks in multiple locations. And as you saw, building houses with Habitat for Humanity in South Africa, as well as in Costa Rica. It's a great product in asphalt. It provides really good properties to improve performance. Paving bricks is, again, a popular application, but this is not just for low-end concrete applications. It goes into precast concrete and poured concrete, and of course can be used a lot in road building and sidewalks and so on. So it's a product that has a great potential and actual use in many, many areas of building and construction. And each plant we're looking at is not that expensive. So typically it's about a $7 million investment for the capital expenditure and the first year of operations. We're looking at about 45 jobs that are created. Again, that huge volume of plastic waste and resinate production, and then a good revenue generation that allows for payback on these investments in a relatively short period of time. About 17 million of revenue per year can be generated. So all in all, we see a really great opportunity to bring the Resonate CRDC solution to the region. What we're talking about here is not just a product, as I said, it's about the impact that we can have on this challenge. The social impact, the environmental impact, as well as the economic impact, of which there are many components. And we're really excited about the prospect and obviously very thankful to ADB for giving us the opportunity to share this with you today. All of this is going to be happening with collaboration in the region. And so we're really looking to partner where we can to find those partners in the waste sector, in the building and construction sector, in the finance sector as well, who are interested to be part of the solution. We want to seek support to build those connections, to look at opportunities to get Resonate products into new construction projects in the region, and potentially participate in other projects that are underway in support of ADB. And of course, investment is welcome, and we're looking to partner with governments as well, where they see this as a viable part of their toolkit to address the plastic waste challenge. So with that, I'd like to hand it back to Erin, and I guess we're going to have a nice time for discussions. Thanks.
Thanks so much, Nick and Donald, for the excellent presentation. I was really inspired by this presentation, not just because of the technology, but also because you have this sort of whole of system approach that also engages the community and addresses social issues such as social housing and education. So, what we always like to say about the circular economy is that, this really needs the participation of everybody in our community for it to be effective. So it's great to see that happening in action with your organization. So with that, we are now going to open this up for Q&A. I see that there are already a lot of really interesting questions coming up in the chat. So if we can just turn it back to Don and Nick to turn your your cameras on, so we can start the Q&A. So I guess maybe just to kick things off, I wanted to go back to, the sort of consistent story that you've been sharing with us about, engaging the community in social issues. Can you tell us a little more about that, and how you were, able to involve not just, the community and kids, but you also have diverse stakeholders, you have NGOs, you have the private sector, you have people working in construction, also working with, people, doing work on social housing. So can you tell us more about how you were able to engage them and keep them kind of part of this ecosystem?
Maybe I could start there. This project actually started at a small, tiny little music school on the beach for really poor kids. It's got very strange and very humble roots. I'm not a musician, but the kids had to help me clean up the beach because I am a developer and we're developing some high-end real estate. And it was like just getting together with kids. What can we do with this stuff? And what we really focused on initially was replanting the mangrove. And so we were able to teach the children about the importance of regeneration, taking these kind of resources that we have, whether they be natural resources, mangrove seeds, or whether they be bits of plastic. We're able to teach kids that you could regenerate your community with the resources at hand. And we just took that seriously. We started to educate. And now today, the REAP program we teach it to kindergarten children. We are talking to Notre Dame University's business school about it. So it's just been this infectious desire within the community. There's a massive thirst to find products that are practical, that people are willing to believe in, that they're common sense, but with a business, an overarching business approach that affects the entire community and the economy. So I think common sense is the answer, Aaron.
Thank you. I love that kind of humble origin story. Who knew that from a music school, we, comes out of this, amazing solution that can also, engage both the community and help to address environmental, sustainability in the, not just in that community, but, in different places across the world. So thanks for sharing that. And, it really just it goes to show that all of these solutions can come from anywhere, and we can need to leverage that to be able to bring innovative ideas out into the world. And then maybe over to you, Nick. We did learn a lot about this interesting material and how it was developed. Can you share a little bit more about what your experiences have been with testing and seeing how this material kind of performs in the real world, and how you're able to see its effectiveness?
Indeed, yeah, I think that's one of the critical things, right? Because the building and construction industry is one of the more conservative industries in the world. Obviously, we want our houses to be solid. We want them to perform in terms of all of the standards that they need to meet. And the products then, of course, need to be performing as well. So that's one of the things I've looked at over time is the testing and the work that's been done to ensure that those standards are met. So there are global standards that CRDC has worked on in relation to the ASTM around compression and strength and fire resistance and so on, even acoustic properties. There are those tests done and passed and exceeded, depending on the levels of resonate incorporation in the product. And at the same time, we have national level standards that we need to meet. So whenever the team is setting up in a new country, they're of course getting the products approved, and their customers are ensuring those products are approved for use. So again, it's something that is a solid product to use in the building and construction industry, and really well supported by independent testing labs.
Excellent. Thanks, Nick. And it's good to hear that this really passes muster, and is something that can be applied, not just in the country, but in different places as well. So I will now go into the chat. We're getting a lot of questions about the material. So first we have a question from Patarapol. Can PVC or PS be used? Or are there any limitations on the types of plastics that you use for your material?
I can
No, go ahead, Nick, please.
Yeah, just to say that, again, that was one of the key issues, right? It's what we faced. For example, chemical recycling, PVC is a no-no. You can't have that. But in this product, we can take everything. So literally, you name the plastic, it can go in. Again, what we're talking about is a commingled residual stream of plastic waste. So what we're really targeting in this region are the problem plastics and the problem applications. So flexibles, sachets, multi-layers where there's multiple polymers, where it's difficult to recycle. So everything can go in. So that's one of the huge advantages. And what I see is really a great opportunity for this to be kind of the vacuum cleaner that can take everything that everybody else doesn't want, right? That's not going into a PET mechanical recycling, an HDPE mechanical recycling, or some of those fractions that go into a polyolefin stream that's more homogeneous, that's going into chemical recycling.
Right. Very important point to bring up. As we know here in the region, that is kind of, one of the biggest issues is those low value plastics. So it's good to know that this type of solution can also absorb that. And it gives, a really kind of comprehensive approach to addressing that issue. I received one question via direct message. For plastics that go into concrete products, how do you deal with the risk of plastic pollution at the end of its life cycle?
That's a really good question, and we get it quite often. And so the microplastic release could be a concern, but one of the very best things you can do with plastic is embedded in minerals. So as soon as that plastic particle, that small plastic particle, is embedded in an asphalt or a concrete matrix, it's physically inseparable. The only way that you can pull it out of that is through heat, through melting it. So we've done extensive tests, and specifically on high transport pavers, and we had utilized what's called a heavy vehicle simulator. There's only 6 in the world. There's one in Costa Rica. Essentially, it's a great big truck that's a computer, and drive over the product 500,000 times. It takes months, and then you can gauge the kind of micro particle release. We find more particle release off of the tires than out of the concrete products. So yeah, it's a big question, and it's a viable question, but the truth of it is, there's probably no better place to sequester microplastics than in a mineral matrix.
Thanks, Donald. We're getting a lot of questions here in the chat. Do keep them coming. And if you would actually like to ask our panelists a question directly, you are welcome to turn on your camera and address it verbally. You just need to raise your hand so I can call on you. So let's get back into these questions. We have another one from Patrick. Is the intent to locate a Resin-8 facility close to a facility that manufactures cement or a facility that produces concrete?
Want to answer that, Nick?
Oh, go ahead, Don. I think that's your expertise.
One of the huge benefits of this industrial symbiosis is we work on both sides of the loop. We work on the plastic waste management side, and we work on the concrete side. So we really have those two options. So the question for us is, where is the very best place to co-locate with a partner? From a science-based perspective, and also a distribution perspective, our very best partners are cogeneration cement plants that are already receiving plastic to combust that plastic to make cement, and then obviously they suffer the CO2 consequence. But the infrastructure is there, and also they have the distribution network. So around the world, we're talking to quite a few large cement companies that we could replace the cogeneration with the utilization of that plastic into their end product. Although we also work closely with waste management companies around the world as well. We're in conversations with both sides of that loop, and both have different business benefits.
Yeah, maybe just to add one point, one of the challenges in this business is distance, right? Because plastic waste has to move from one place to another to be processed. So one advantage is this technology obviously is a great way to densify plastic and reduce the CO2 footprint of the transportation. So again, there are benefits to locating at a cement or concrete facility. There are benefits to locating where maybe the waste is being already sorted, so that we can densify it at that immediate stage.
Thanks both. Okay, so let's keep going to these questions. We have another question here from Ina. Does Resin-8 core still capture CO2 once it's within the final product via its surface, for example, a building block?
Ideally, no. Hi, Ina. I know Ina, so it's hello, Ina. Ideally, no. The idea is when we coat the Resin-8 particle with calcium hydroxide and we expose it to flue gas, we want it to completely react. We want it to completely react and turn into calcium carbonate. So if it still did absorb and could some CO2 in its form as a block, it would be because it didn't completely react during the conversion phase. So ideally no, but the answer is possibly yes.
Great, thank you. All right, let's keep going down. We have one question from Ryan, and it's kind of related to the question that was asked earlier. When building materials degrade, there could be a potential risk of chemicals, microplastics, pollutants being released to the environment. How have you addressed this?
That's the leaching question.
Yes.
We also get the leaching question a lot, so we've done a lot of studying on leaching as well. There's a lot of ASTM testing to determine whether or not there's leachates in your product. So we've done all of that testing, and again, we go back to kind of practicality. When a small particle of plastic is completely encrusted and embedded within a mineral matrix, it's really very hard for those chemicals to transport themselves out. It's actually quite common for hazardous materials to be encapsulated in concrete. So one of the very best places to deal with the microplastic release and the leachate, again, we would think, and testing would show us that it is actually to entomb it in mineral.
Maybe one thing to add as well, that the construction and demolition waste market and the recycling of building materials is something that's really growing. So here in Singapore, there is no landfilling, there's no disposal allowed of demolition waste. It has to be recycled. And you've got a perfect material when you crush up a building block or a piece of concrete to be the raw material for the next generation of concrete. So in that process, as Don indicated, the plastic particles are part of the concrete matrix, and so effectively can then be reused in the next building product. And so that's why we do see this as a circular solution, although on a much longer timescale, hopefully, as buildings survive for a long time.
Thank you. We have one question from Antonio, also kind of related to Ina's earlier question. Resin 8 core and DAC, can it also help capture CO2?
I'm sorry, I don't know what the deal. I don't know the acronym.
Okay. Okay. All right. Well, let's go ahead to the next question. Also near sorry. Okay, here's two questions from Hang. How do you think national governments within ASEAN or Southeast Asia can build upon current work to enhance the plastic circular economy? And then what kind of technical capacity and information can support member states to help advance the plastic circular economy in their countries?
Maybe I can start off on that one. So what I really love about this solution is that it's complementary to initiatives that are underway. And it's complementary to several parts of an economy, whether that's in a city or obviously in a wider country. So these technologies and the ability to utilize waste plastic as a valuable material, especially the low value material that's not captured today, is something that we want to be working on with governments. And Don has been extremely successful in Costa Rica on doing that, and also working with the United Nations Development Program in Costa Rica on these kind of programs. So we want to be part of that ecosystem. We want to be a complementary solution for addressing the issue, both on the collection side as well as on the processing side, ensuring that we are using waste plastic in the best way possible. And again, not displacing mechanical recycling, for instance, where we want to get those bottles back into bottles. So that discussion with governments is super important, because we need to help them to see the holistic solution and how we can be a part of that.
Yeah, we've been very fortunate to deal with some of the best testing laboratories in the world and policymakers. So we work, like Nick said, closely with the United Nations, and over the last probably 18 months, we're starting to be approached by governments. Governments have a big problem on their hands, and as soon as we were able to show, listen, we figured this out from a technological perspective and a testing perspective. This is a good product for the construction sector. And again, construction sector testing is extremely stringent. To be able to put your product into some of these high grade buildings is a tough process. But as soon as you get through that process, and again, governments see a practical and economic solution, there's a lot of doors opening for us all over the world right now.
Thank you. And maybe I'll just add to that from the perspective of our current project here at ADB. So as I mentioned at the introduction, we do have a regional technical assistance project as part of a larger program at ADB to address plastic pollution as well as promote circular economy approaches. It's kind of embedded in our environmental action plan for the region. And so we have been working with countries in Southeast Asia to build their capacity, build their knowledge, and also to provide, kind of more practical guidance and solutions to kind of strengthen and expand the circular economy for plastics. So, in our project, we've been working with Indonesia, the Philippines, Vietnam, and Thailand to kind of build institutional capacity in things like finance and data collection and management. We've been providing guidance on how we can look at the potential for different technologies, especially digital technologies, for improving the performance of circular systems, monitoring plastic waste that's in the environment, and basically helping them to make better informed decisions for addressing plastic waste and promoting a circular economy. So this is just one of the ways that ADB has been helping, and these feed into our larger investment projects. We have ongoing projects in recycling of plastic bottles in the region. We're also working on policy-based lending programs. So we just approved one last year in Indonesia to help the government in its marine debris reduction goals. So there is a lot going on, and ADB is obviously just one player in many different partners that are working in the region, and we're working across different sectors as well to promote circularity for plastics, everything from waste management and urban services and, environmental management and coastal and marine management as well. So, we also believe in the sort of whole of system approach, similar to what CRDC has been doing with their solution. So, we believe that we need to kind of work together and holistically to address plastic pollution. All right, let's keep going on these questions. So we have one question from Ryan. How do we ensure prioritizing reduction of over plastic production as a solution over recycling? So this is more of a, upstream versus downstream solution.
I think it's a great question, and I think it's something that we're all tackling at the moment. And the waste hierarchy is something we always go back to, and CRDC, I think, believes in that very much as well. We have to have smart use of plastic materials, right? We need to think about the best way to, the best material for the job from a carbon footprint and from a practical footprint as well, or practical approach. And we need to ensure that reuse models are coming into play, that we have the right use of plastics in products overall. That's something that's been, I think, inherent now over several years in the industry. And again, there is going to be the use of plastics going forward, and there are going to be challenges in recycling some of those plastics. And so we need solutions like this that are complementary in that waste management hierarchy. What we don't want is plastics going to incineration, where they can be used in a more valuable way. And we certainly don't want them in landfill, and we absolutely don't want them in the environment. So we need to get that material into a product, and this product, Resonate, is something that can take exactly those fractions that are lost today.
And I believe that long term, and I'm going to come back to education. It's about education. We teach children, if you don't need to use plastic, don't use it. If you don't need to consume, don't consume. So a big, huge part of this, one of the ways to lower the amount of plastic we utilize is to teach people that we probably don't need to use as much plastic as we do today. And so education is at the critical end of this. It's like the next generation will be the ones that probably teach this generation the better utilization of plastic.
Absolutely. And you bring up a good point about how consumer behavior is also just as much of a factor here, in addition to, addressing design and production and, treatment and recycling. It always goes back to the sort of holistic approach, and, consumers, regular folks like you and I, can also do our part to reduce the amount of waste. And with the waste that is out there, we can do things with them. We have solutions for them so that they maintain, value for our communities, but also, reduce their impacts on the environment.
And just to add on the Bag That Builds program that CRD has pioneered, it really is solving one of those key challenges, right? When we all think about, can I put this in my recycling bin or not? Or actually, even if some communities, they don't have a curbside collection for segregated recyclables. The answer is very simple here. Every piece of plastic goes in that green bag, and every piece of plastic you put in that green bag is going to make its way into a Resonate product. And the good thing as well is, while it's always better that material is contamination free, if you like, it doesn't really matter for Resonate. So low levels of contamination are acceptable. And a lot of those plastics that we pick up off the beaches during our cleanups or that we pull out of rivers, that level of contamination is perfectly acceptable. And if there's a little bit of sand in it, no problem, right? Because it's going to anyway into a construction product.
Better yet. Yeah.
Great. Thanks so much. All right. We have a question here from John Erico. This is such a nice presentation. I would just like to ask about the waste in production. How do you manage the waste being produced throughout the process? And then as a follow-up question, okay, well, I guess you answered this earlier about the risk of plastic polymers being released into the immediate environment.
It's truly a zero waste production process. So we don't have any production waste. We utilize all of the plastic that comes into our facility. We realized early on when we first developed the technology that water was going to be a big issue. So part of our patent is what we call dry cleaning. The reason that we put calcium hydroxide in the first pass or the first instance is because it decontaminates. Calcium hydroxide is highly alkaline. So we call it dry cleaning. So we dry clean the plastic with the mineral additives. And then when we extrude them, because we can commingle any kind of plastic, everything that comes into our facility is turned into Resonate. Now, if there was maybe some contaminants like wood or steel, we have to pull those out. But in terms of the plastic, it is truly, and I think one of the world's only zero waste process, and right down to making sure that we recycle our cooling water. So a lot of our electricity in Costa Rica, a third of our electricity comes from solar panels. So it's truly looked at every aspect of how do we create a zero waste system.
Thank you. All right, let's keep going. We have another question from Patara Paul. Is the cost competitive compared with virgin sand?
In our costing process, we can't cost ourselves against the price of natural sand, but we cost ourselves with other high grade lightweight aggregates. So at a high weight lightweight aggregate, yeah, we're definitely cost competitive. In an interesting study we just did in a Saudi Arabian project, we looked at everywhere that we could put Resonate in a block, an entire block of housing. And then we determined what the additional cost to put our Resonate in that housing block was. And then we determined what the actual sales value of that for that developer. And it comes out at 0.15% of development. So it's a negligible cost, but from a marketing perspective and then, well, in a building quality perspective, it's got very, very high value. So there's a very strong cost benefit relationship using Resonate.
And it's important to recognize that Resonate is used not to displace all of the natural aggregate in concrete, of course. So it's in that 5, 10, 15% range, depending on the application.
Thank you. All right. We have a question from Kevin. Does the technology require cleaning of the contaminated or soiled plastic materials prior to being processed?
No. No, everything goes into the pot. We can take about 10% organic waste. We extrude this product at 220 degrees in that neighborhood, 220 degrees Celsius. So any organic material is carbonated as it comes out. And actually that kind of helps us in a way because we always want the product to come out at a shade of gray. We call it 50 shades of gray. We want it to come out some shade of gray or another so that it looks just like natural aggregate. And that coloring generally comes from any residual organic material that was on the product.
Great, thank you. So we have 7 minutes left in our session. So we will ask our last few questions and then I will ask for a parting shot from both of our panels and then we will wrap up. So last few questions here. We have a question here from Danny. What are the advantages of Resonate, or I guess Resonate?
Yep. Do you want to do the event?
So again, we've spoken a little bit about that in terms of the benefits that it can provide. Again, the testing has shown, again, against all the tests that need to be done in a typical concrete formulation, the performance, right? So acoustic performance in roads, for example, is an interesting one. The effect on runoff in roads from water being transported through the asphalt. There's a lot of tests that have been done there showing, again, beneficial effects. On the concrete side, again, it's about the light weighting, especially. It's a great experiment when you pick up a bucket of normal sand or aggregate and you pick up a bucket of resonate. The difference is dramatic, right? So we're talking about a significant 75% weight saving, right? The resonate can be significantly lighter. So that's beneficial not just in the material itself, but again, concrete is transported typically. So if you can reduce that amount of weight when you're transporting concrete, so much the better, right? To achieve lower carbon emissions from that concrete cement truck that you see on the road. Again, Don, maybe you want to go into some of the other detailed studies that have been done on performance.
Yeah, thermal properties are a big thing. Housing comfort, for instance, house insulation. So it provides actually a surprising degree of thermal advantage. And along in that same vein is acoustic. The houses are, or the buildings are, or better acoustic, have better acoustic values. There's also resonate has a dampening effect in the concrete. Concrete is typically very brittle, and so this small amount of plastic, which is quite flexible, provides a dampening effect. And if we mix it just with exactly the right, what we call mixed design, we can often get increased strength. Always better impact strength, sometimes better increased compression strength. So we can use a small amount of what was typically waste plastic and actually improve our concrete products.
Thank you. All right. So we have kind of both Simon and Ina have asked in the comments about competition and, other sort of players in the market. Do you have any competitors, or do you face some opposition from operators of incineration plants as you literally divert their feedstock, which then digs into their business model?
Maybe I can take it a little bit to that second part first, and Don can get into the details on the competition. Again, when you look at RDF, refuse-derived fuel that's used in cement kilns, if you're in a cement plant, they operate in a very narrow window of temperature, right? So they cannot have it obviously too cold, and they cannot have it too hot. And the more plastic that they have in RDF, the hotter the combustion is, and more difficult it is maybe to control the temperature in the cement kiln. So there is a lot of organic material that actually is going into refuse-derived fuel. And so another thing I like to say is there's more than enough plastic waste to go around. So we are not short of plastic waste. So again, there's not going to be an issue with cement kilns, for example, not getting the RDF that they need. I think there's still more than enough out there. And again, plastic is only a part of that RDF stream.
Yeah, and from competition in the marketplace, there has been all kinds of for decades of people trying to mix plastic particles with cement to lightweight it. Polystyrene beads would be the norm. The problem with typically mixing plastic with concrete is the cement paste has to adhere extremely well. Otherwise, your concrete product isn't working at its mechanical optimum. What we were able to do with resin 8, and especially the small sand particles, was, in fact, we were able to patent this, make it stick mechanically because of the very textured face and the open cell network of the particle itself, and stick chemically because there is these spots of calcium hydroxide and pozzolan. So resin 8 sticks extremely well, adheres extremely well to concrete products. And the size and gradation, how it mixes in cement, is also very, very important. So we're the only sand substitute that we know in the world that follows the exact size and gradation and adherence value that our standard aggregates would. So right now, we don't have any competition.
That's very exciting. All right. So last question from me as we close up this webinar. Where do you think are the opportunities for introducing or scaling up this solution here in Asia and the Pacific?
Well, maybe I'll go first and give Don the last word. So again, I'm really excited about bringing this product to the region. Again, we see, for example, small island developing states or island communities where economically recycling plastic is just not going to happen given the volumes that we're talking about, but they can and they do build, right? So they're building with concrete on these in their communities. So again, opportunities in countries where we can look at more remote locations. But of course, this is a solution in the middle of a city as well, right? So we don't necessarily see ourselves kind of constrained by location in that sense, but the benefits can be different if you're in a city or if you're, for example, in a more remote area. So again, across the region, huge challenges and great opportunities to bring this product forward. Don, over to you.
And as I mentioned, we're a purpose-driven company. Our purpose is to deal with as much plastic as possible and build as many assets as we can. Asia has both. You have an incredible building cycle that you're going through, and you have an incredible amount of plastic. And so Asia is definitely on the top of our list. We've done some pretty serious business development already, specifically in Indonesia and India, and now I don't know if Saudi Arabia is considered Asia, but in small island developing states like Samoa. So yeah, our purpose is to deal with as much plastic as possible, and that means we have to be in Asia.
Fantastic. And so I want to then wrap up this webinar. And thank you very much to our speakers today, Donald Thomson and Nick Kolesch, for this really interesting story and presentation about your solution, and for, kind of sharing with us, where this can be applied in Asia and the Pacific. And I want to thank all of you in the audience for joining today and for your very active participation. We hope that you will attend our future webinars. Before you go, you will be receiving a link to answer a survey about this webinar. So please do answer our survey, and we hope to see you again. And if you would like to come back and watch the session again, we will be uploading the recording to our Circular Economy data room. With that, have a great day or a great evening, and see you next time. Bye.
Thank you. Bye. Thank you.